Exploring ancient city engineering through modern technology. The engineering feats of ancient cities have long captivated historians, archaeologists, and architects, from the iconic pyramids of Egypt to the intricate water systems of the Indus Valley civilization. Ancient cities were marvels of ingenuity, built without the sophisticated technology we take for granted today. However, thanks to modern technology, we can now explore and understand these feats with unprecedented detail. Here's an exploration of how modern tools and methods are helping us understand and even replicate the engineering brilliance of ancient cities. 1. Geospatial technology, mapping and visualization. One of the key technologies helping us explore ancient city engineering is geospatial technology, particularly LIDAR, light detection and ranging, and satellite imagery. LIDAR uses laser pulses to map the surface of the Earth with incredible precision, even through dense vegetation. This technology has allowed archaeologists to uncover hidden ancient cities, structures, and networks that were previously obscured by forests or other natural obstacles. For example, LIDAR revealed the vastness of the ancient Maya city of Tikal in Guatemala, showing complex networks of roads and buildings that were previously unknown. Satellite imagery. Modern satellites can capture high-resolution images of archaeological sites, revealing details about urban layouts, infrastructure, and landscape modifications. This has been pivotal in studying ancient cities such as Babylon and Rome, where satellite imagery can help researchers understand how the cities were organized, the scope of their construction projects, and their long-term development. 2. 3D modeling and simulation. 3D modeling has transformed how we understand ancient city planning and construction. By using data from LIDAR, satellite imagery, and excavation records, archaeologists can create detailed, interactive digital models of ancient cities. Reconstruction of ancient cities. With these 3D models, scholars can recreate entire cityscapes as they might have appeared in their heyday. For example, using this technology, we can digitally walk through the streets of Pompeii or Athens, and study architectural elements such as temples, theaters, and urban grids, all reconstructed with great accuracy. Urban planning analysis. Simulations can also show how cities developed over time. The gradual expansion of Rome, for instance, can be modeled and analyzed for insights into how its infrastructure, such as roads and aqueducts, was organized. By simulating ancient traffic patterns or water distribution systems, researchers can gain insights into the urban planning strategies that made these cities so resilient and effective. Structural analysis, virtual testing and reconstruction. Modern computational tools allow us to analyze the structural integrity of ancient buildings and monuments. By using finite element analysis, FEA, and other advanced engineering simulations, researchers can test how ancient structures withstood earthquakes, weathering, and other environmental stresses. The pyramids of Giza. Engineers have used modern computational models to simulate the forces that acted upon the Great Pyramid during its construction and through the centuries. These simulations help clarify how ancient engineers managed to build such enormous structures with such precision, despite having limited tools and resources. Roman concrete. One of the most intriguing engineering discoveries involves Roman concrete, which was used in many of their buildings and aqueducts. Modern scientists have analyzed the chemical composition of ancient Roman concrete, revealing that it has properties that make it more durable than most modern concrete. This discovery could inspire new building materials for sustainable construction today. 4. Materials science. Understanding ancient construction materials. Ancient builders had access to a wide variety of materials, and studying how these materials were sourced, processed, and used has been a key focus of modern technology. Microscopic analysis. Tools like electron microscopes allow scientists to study the mineral composition of ancient stones, metals, and ceramics at a microscopic level. This has been essential in understanding the creation of durable materials like Greek marble, or the concrete used by the Romans. Nanotechnology. Some ancient materials, particularly in structures like the Roman Pantheon, have been found to exhibit properties that modern materials scientists are still trying to replicate. For example, the Pantheon's massive concrete dome, which is still the world's largest unreinforced concrete dome, was made with a mix of volcanic ash, lime, and seawater that gave it exceptional strength. Modern studies of this material have uncovered insights into its lasting durability. 5. Drone technology. Surveying and excavation. Drones have revolutionized the way archaeologists survey and excavate ancient cities. Drones equipped with high-resolution cameras and sensors can capture vast areas quickly and in high detail, which would be impossible or prohibitively expensive to achieve with traditional methods. Aerial photography. Drones can capture detailed aerial images of ancient ruins, enabling archaeologists to study large, sprawling sites from above. For instance, drones have been instrumental in the excavation of Teotihuacan in Mexico, helping to uncover new aspects of the ancient city's urban grid and architectural layout. 3D scanning. Drones also carry 3D scanning equipment, allowing for accurate modeling of structures or even entire neighborhoods. These models can then be used to assess the condition of the site, guide conservation efforts, or even predict future erosion or damage. 6. Virtual reality, VR, and augmented reality, AR. Virtual reality, VR, and augmented reality, AR, are opening up new possibilities for interacting with ancient cities in a more immersive and intuitive way. By merging ancient city reconstructions with VR or AR, visitors and researchers can experience these places as they might have looked in their prime. Touring ancient cities, VR has enabled the creation of virtual tours of ancient sites like Rome, Athens, and Cairo, where users can walk through reconstructed temples, marketplaces, and homes. This provides an invaluable tool for both education and preservation, allowing modern audiences to understand ancient urban life firsthand. AR and excavation. AR tools can overlay digital models onto the current state of a site, allowing archaeologists to see how the site looked in the past as they work in real time. This helps with site interpretation and can inform conservation and restoration decisions. 7. Smart materials and sustainable replication. One of the key aspects of ancient city engineering that has received attention today is the sustainability of their building practices. Many ancient cities were highly resilient and environmentally harmonious, using locally sourced materials and energy-efficient designs. Smart materials. Modern architects and engineers are exploring how to replicate ancient building practices using smart materials. For example, self-healing concrete and eco-friendly building materials inspired by ancient techniques are being explored to create more sustainable cities in the future. Energy-efficient designs. Some ancient cities were built with energy efficiency in mind. The ziggurat of Ur, for example, used the surrounding environment to moderate temperatures, while Roman baths and other public buildings were designed to efficiently manage water and heat. Modern architects are incorporating similar ideas into their designs for sustainability. Conclusion. Modern technology has given us powerful tools to explore, understand, and even replicate the engineering feats of ancient cities. Through geospatial technology, 3D modeling, structural analysis, and materials science, we can uncover the sophisticated methods used by ancient civilizations. Not only does this deepen our understanding of the past, but it also provides valuable lessons for modern engineering and sustainable urban development. As we continue to use cutting-edge tools to analyze ancient cities, we gain a richer appreciation for the brilliance of ancient engineers, whose work continues to influence the world today. Next steps. Leveraging ancient engineering insights for modern challenges. As we continue to explore ancient city engineering through modern technology, it's not just about historical curiosity. These insights can help address some of today's most pressing challenges. By studying the sophisticated designs of ancient cities, we can apply their solutions to contemporary problems in urbanization, sustainability, and resilience. Let's delve into some ways ancient engineering might inspire future innovations. 1. Urban resilience and disaster management. One of the greatest challenges facing modern cities is their vulnerability to natural disasters like earthquakes, floods, and climate change. Ancient cities, particularly those in seismic or flood-prone regions, were often designed with resilience in mind. Studying how ancient civilizations adapted to their environments can offer valuable lessons for modern urban planning. Seismic engineering. In ancient Greece and Rome, the Romans and Greeks constructed buildings and urban spaces that were remarkably resilient to earthquakes. They employed techniques such as flexible, lightweight construction and seismic dampening strategies. For example, the ancient Greek temple of Hera at Bossae used a combination of stiff columns and flexible joints to withstand ground shaking. Today, these principles have been revisited in the development of earthquake-resistant buildings. Flood management. In ancient Mesopotamia and Egypt, Ancient engineers in cities like Babylon and Cairo used complex systems of dikes, canals, and sluices to control water and prevent flooding, demonstrating early principles of hydraulic engineering. Modern urban centers, particularly those built on floodplains, are now exploring similar approaches using green infrastructure like permeable pavements, stormwater retention systems, and urban wetlands to mitigate flood risks. Climate-responsive architecture. Many ancient cities were built with an acute awareness of their environment, incorporating natural cooling, heating, and shading strategies into their designs. The Hellenistic city of Alexandria used large open courtyards and wind-catching towers, while ancient Persian cities like Persepolis were strategically located to benefit from natural breezes in the summer. Modern architects are exploring similar passive cooling techniques to reduce the need for energy-intensive air conditioning in cities affected by global warming. 2. Sustainable urban design and resource efficiency. Sustainability was embedded in the core of many ancient cities, whether through the use of locally sourced materials, water conservation methods, or energy-efficient designs. Modern architects and urban planners can look to these practices to create more sustainable and resource-efficient cities. Resource-efficient building materials. Ancient cities like Rome and Machu Picchu were built using locally sourced materials that required minimal transportation. The use of Roman concrete, which had exceptional durability and was made from locally abundant volcanic ash, is an example of how ancient engineering minimized resource use while maximizing strength. Today, materials science is investigating ways to replicate these ancient practices, including using bio-based and recycled materials in construction, such as hempcrete or mycelium-based bricks. Water management systems. Ancient cities had highly sophisticated water management systems, which were critical for their survival and prosperity. For example, the aqueducts of Rome and the water harvesting systems of Petra allowed ancient cities to thrive in arid climates. In modern times, cities like Singapore and Melbourne are implementing similar systems, such as rainwater harvesting and desalination, to manage water scarcity while using green infrastructure to mitigate runoff and recharge aquifers. Waste management and sanitation. The Indus Valley Civilization's advanced sanitation systems are among the earliest known examples of urban waste management. They featured an elaborate system of drains, wells, and public toilets. These systems were likely an early response to urbanization, providing solutions to avoid contamination of water sources and to manage public health. In the modern world, these ancient systems are inspiring innovations in wastewater treatment, composting toilets, and closed-loop sanitation systems, key to building sustainable urban environments. 3. Smart city technologies inspired by ancient wisdom. While today's cities are often labeled as smart due to the integration of digital technologies, ancient cities also had their own version of smart technologies based on human observation and ingenuity. By examining how these ancient cities optimize daily life, modern cities can develop smarter, more efficient systems. Energy-efficient design and passive cooling. Ancient cities such as Machu Picchu or Persian Isfahan employed solar orientation to ensure buildings made the most of natural light and heat. This passive design, using the sun's position for heating or cooling, is a principle being revived today in the form of solar passive houses and energy-efficient buildings. Traffic and transportation management. The Roman road system and Maya trade routes were among the most advanced transportation networks of their time, designed for efficient movement of goods and people. Today, cities like Copenhagen and Tokyo are developing smart transportation networks that incorporate real-time data from sensors and cameras to optimize traffic flow, reduce congestion, and improve public transport reliability. Decentralized energy grids. The ancient practice of local energy generation and storage, such as windmills used in ancient Persia or water wheels in medieval Europe, can inspire modern decentralized energy systems. Today, cities are experimenting with microgrids, which use renewable energy sources like solar and wind to create localized, sustainable energy systems that can operate independently from larger, centralized grids in case of an emergency. 4. Human-centered urbanism. Lessons from ancient public spaces. Ancient cities were designed with an emphasis on public space, community, and human interaction. Whether in the grand agoras of ancient Greece or the vast marketplaces of Mesopotamia, these urban areas were centers of social, political, and economic life. Modern urban planners can learn from these spaces to create more inclusive and human-centered cities. Public spaces for social interaction. the Forum in Roman cities, the Agora in Greek cities, and the squares in medieval towns were not only centers of commerce but also places where people gathered, debated, and participated in public life. Today, planners are revisiting the concept of public space to create more walkable cities and encourage social interaction. Modern examples include the transformation of car-centric spaces into pedestrian zones and the creation of urban parks and plazas. Mixed-use urbanism. Ancient cities often featured mixed-use buildings where residential, commercial, and civic functions coexisted. The Romans, for example, created spaces like the insulae, apartment buildings, which housed both living and commercial spaces. Today, there is a renewed interest in mixed-use development to reduce urban sprawl, improve local economies, and create vibrant neighborhoods. 5. Integrating ancient knowledge into modern education. The rediscovery of ancient engineering wisdom, combined with modern technology, provides an opportunity for interdisciplinary learning. Educational institutions around the world are increasingly focusing on how ancient knowledge can be applied in modern engineering and architecture. Interdisciplinary research. Universities are now engaging in interdisciplinary research, combining fields like archaeology, engineering, materials science, and architecture to understand ancient techniques and their relevance to contemporary problems. For example, studying Roman road building techniques not only sheds light on historical practices but can inspire modern solutions for durable, low-maintenance infrastructure. Hands-on learning. Some universities and institutions are creating experimental projects where students and researchers replicate ancient construction techniques using modern tools. This allows students to gain hands-on experience with both ancient and modern building practices and understand the historical significance of materials, construction methods, and urban design. Conclusion: a future built on the past. The exploration of ancient city engineering through modern technology is not just an academic pursuit, it offers a blueprint for solving contemporary challenges in urban living, sustainability, and resilience. By learning from the principles embedded in ancient civilizations, such as the Greeks, Romans, Mayans, and Indus Valley people, we can draw on timeless knowledge to build cities that are more sustainable, livable, and resilient. As modern cities face the pressures of overpopulation, climate change, and resource depletion, the lessons of ancient city engineering, whether it's the wisdom behind water management, public spaces, or building resilience, can help us design the cities of tomorrow. By using modern technology to uncover, understand, and apply these principles, we can build a future that is rooted in the brilliance of the past. In this way, the engineering feats of ancient cities are not relics of the past, they are living models that guide the development of the cities of the future. Preserving ancient knowledge for future generations. As we explore and harness ancient engineering insights, it's essential to preserve this knowledge, not just for academic research, but as a resource for solving real-world problems today. The integration of ancient methods and technologies into modern education, conservation, and urban planning ensures that the lessons of the past continue to influence the future. 1. Digital preservation of ancient sites and knowledge. Modern technologies like 3D scanning, digital archiving, and virtual reality, VR, are playing a crucial role in the preservation of ancient cities and their engineering marvels. These tools not only help conserve these sites but also allow future generations to explore and study them in a way that was previously impossible. 3D scanning and modeling. Many ancient buildings, such as the Roman Colosseum, the Great Wall of China, and Angkor Wat, have been digitally scanned to create high-resolution, interactive 3D models. These models can be used for virtual tourism, academic study, and restoration projects. They provide a permanent digital record that ensures the details of these ancient sites are preserved, even in the face of natural disasters, wear, or human encroachment. Virtual reality, VR, and augmented reality, AR, VR and AR are transforming how we interact with ancient engineering knowledge. VR allows users to walk through historical sites as they would have looked centuries ago, while AR overlays digital reconstructions onto the physical world. For example, the Parthenon in Athens is being recreated in VR, allowing modern audiences to experience it in its full splendor, complete with its intricate sculptures and decorations. This immersive experience is not only educational but also an important tool for preserving ancient knowledge and methods in a dynamic, engaging way. Digital libraries and databases. Many universities, museums, and research institutions have created digital archives of ancient texts, engineering manuals, and architectural plans. These archives can be accessed by scholars, architects, engineers, and the public, ensuring that ancient knowledge remains available for future study. For instance, the cuneiform texts of Mesopotamia, which contain early records of engineering and architecture, are being digitized to offer insights into ancient construction practices and urban planning. 2. Collaboration between traditional crafts and modern innovation. While technology plays a key role in preserving ancient knowledge, there is also value in collaborative efforts between traditional craftsmen and modern engineers. Reviving ancient construction techniques using modern tools can bring new life to traditional practices, while also creating innovative solutions for contemporary urban challenges. Reviving ancient craftsmanship. Many ancient civilizations had master builders who created durable, highly functional structures using limited resources. In places like Egypt, Greece, and China, the knowledge of traditional masonry, stone cutting, and architectural detailing has been passed down through generations. Today, architects and builders are teaming up with skilled artisans to revive these ancient techniques in modern construction projects. For example, in restoring the Temple of Karnak in Egypt, artisans are using traditional stone cutting tools alongside modern machinery to ensure historical accuracy while benefiting from modern advancements. Blending ancient techniques with modern technology, 3D printing, robotics, and AI-based design tools are being integrated with ancient construction techniques. In the development of sustainable housing projects, these tools can replicate the efficiency and resourcefulness of ancient building methods. For instance, using natural materials like mud brick or rammed earth in combination with 3D printing allows for the construction of low-cost, environmentally friendly homes. These homes not only draw inspiration from ancient practices but also incorporate modern efficiency and precision. 3. Engaging communities in preservation and education. The preservation of ancient engineering knowledge is not just the responsibility of scholars and institutions, it also requires active engagement from local communities. Many ancient cities and archaeological sites are located in regions where the communities themselves have a vested interest in preserving their heritage. Community-based conservation. In regions like Peru, Mexico, and Turkey, local communities have taken an active role in the conservation of ancient structures and cities, often partnering with international organizations and academic institutions. These collaborations not only help conserve physical sites but also ensure that the traditional knowledge of local artisans, builders, and engineers is preserved and passed down through generations. Educational outreach and public engagement. Increasing public access to knowledge about ancient engineering through educational programs, workshops, and digital tools fosters a greater appreciation for the ingenuity of past civilizations. Virtual museums, educational apps, and interactive exhibits provide a platform for people of all ages to learn about ancient construction techniques, architecture, and urban planning. Local tours, involving students or community members as guides, can help share knowledge and create deeper connections between heritage and modern life. Archaeological tourism and cultural heritage. In many parts of the world, archaeological tourism is a key economic driver, but it also presents opportunities for cultural exchange and preservation. Cities like Athens, Rome, Petra, and Machu Picchu are visited by millions of tourists each year, providing both a financial incentive for conservation and a platform for educating visitors on the significance of ancient engineering. Careful management of these sites ensures that tourism helps sustain local economies while fostering respect for the ancient knowledge embodied in these places. 4. Applying ancient wisdom to contemporary urban challenges. Finally, beyond historical preservation, applying ancient engineering wisdom to contemporary challenges can have far-reaching benefits. As cities grow and face mounting challenges, the sustainable, resilient, and efficient solutions of ancient civilizations provide a rich source of inspiration. Greening urban spaces. Ancient cities often employed strategies to blend built environments with nature, creating green spaces and systems that enhance both human life and the environment. For example, the Hanging Gardens of Babylon, though often debated in terms of historical accuracy, are an example of the ancient world's ambition to incorporate natural elements into urban life. Today, urban greening initiatives, such as vertical gardens, green roofs, and urban forests, are gaining traction as cities confront the urban heat island effect and air pollution. Energy efficiency and renewable energy. Ancient civilizations had a deep understanding of their environment and often optimized natural resources like sunlight, wind, and water for energy needs. For instance, the wind towers of Iran or the solar alignment of many ancient Egyptian temples helped optimize environmental energy flows. In modern cities, solar energy, wind power, and geothermal heating are being integrated into smart urban grids. The combination of ancient wisdom and modern technologies can help reduce reliance on fossil fuels and create more sustainable urban environments. Social and economic urban design. Ancient cities often reflected a deep understanding of social organization and urban design, with spaces designed to foster interaction, cooperation, and community well-being. The Roman Forum or the Greek Agora were central places where individuals engaged in civic, social, and economic activities. Modern urban planners are increasingly focusing on community-oriented spaces that promote social cohesion and equality. The principles of mixed-use development, pedestrian-friendly spaces, and the emphasis on accessibility and inclusivity are deeply rooted in ancient design traditions and are being revived in contemporary urban planning. A bridge between past and future. The convergence of ancient engineering with modern technology offers an unparalleled opportunity to not only unlock the mysteries of the past but also address some of the most critical challenges of the present and future. By using advanced tools like LiDAR, 3D modeling, digital preservation, and VR to explore ancient cities, we gain not just a deeper understanding of their architectural feats but also the chance to learn from them in practical, sustainable ways. Ancient cities, built without modern machinery or materials, employed ingenious solutions to optimize their environments, sustain their populations, and ensure their resilience. Today, as we face challenges like climate change, urban sprawl, and resource scarcity, these timeless principles offer valuable lessons. By integrating ancient knowledge into modern urban design, we can build cities that are not only sustainable and resilient but also deeply connected to their cultural and historical roots. As we continue to blend ancient wisdom with modern innovation, we can create cities that are more harmonious with the environment, more equitable for their residents, and more resilient in the face of future challenges. In doing so, we ensure that the engineering feats of the ancient world are not only preserved but also serve as a foundation for a brighter, more sustainable future. Reimagining the future of urban development, merging ancient and modern practices. The integration of ancient engineering wisdom with cutting-edge technologies presents exciting possibilities for reimagining urban development in the future. By blending lessons from the past with the innovations of today, we can create urban environments that are not only technologically advanced but also grounded in sustainability, human well-being, and cultural richness. As the challenges of modern urbanization continue to grow, this fusion of ancient and modern knowledge offers a compelling pathway forward. 1. Building the smart, sustainable city, a modern-day reinterpretation of ancient principles. Cities are growing rapidly around the world, and urban planners and architects are increasingly focused on creating smart cities that can integrate technology with urban infrastructure for better efficiency, sustainability, and livability. Yet, there's much to learn from the ancient cities, which were early examples of smart design and sustainable development. By revisiting these ancient concepts, we can reinterpret them in the context of modern needs. Resource efficiency. Ancient cities, such as those in Mesopotamia or the Andes, often made use of locally available materials, minimizing transportation costs and environmental impact. Roman concrete and Egyptian limestone were extracted and used with extraordinary precision, without the need for mass production or extensive supply chains. Today, the emphasis is on using recycled materials, bio-based building materials, and local sourcing to minimize a city's carbon footprint and support a circular economy. In cities like Amsterdam, Copenhagen, and Vancouver, the focus is on creating urban systems that recycle water, energy, and waste, much like ancient civilizations did in their own way. Solar design and urban green spaces. Ancient cities were often strategically planned to take advantage of natural light and wind patterns, reducing the need for artificial heating or cooling. In ancient Egypt, the layout of homes and public buildings was designed with the sun's path in mind, optimizing natural light during the day and cooling winds at night. Modern passive solar design principles now guide the creation of energy-efficient buildings that maximize natural light and reduce energy consumption. Additionally, green spaces, from the hanging gardens of Babylon to ancient Roman villas, were integral to urban environments, providing relief from the heat, improving air quality, and supporting biodiversity. Today's architects are reintroducing the concept of urban parks, green roofs, and vertical gardens to make cities more livable and sustainable. Decentralized energy and water systems. Ancient cities like Rome, Babylon, and Indus Valley had sophisticated water management systems that included aqueducts, wells, and drainage networks that ensured sustainable water use. These systems were designed to minimize waste and optimize water usage. Today, modern smart grids and solar-powered microgrids offer decentralized energy solutions, much like the localized energy practices of ancient civilizations, such as windmills or water wheels. Similarly, contemporary cities are focusing on decentralized water harvesting systems, often inspired by ancient rainwater collection techniques. 2. Circular cities, creating a model of sustainability based on ancient practices. One of the most exciting avenues for the future of urban development is the creation of circular cities, which aim to eliminate waste and make the most of all available resources. Ancient civilizations were pioneers in resource-efficient designs and recycling. The concept of the circular economy. The Indus Valley Civilization, one of the earliest urban centers, had advanced waste management systems, including drainage systems that carried waste away from living areas. In the modern context, the concept of a circular economy seeks to recycle all materials in an urban ecosystem, much like how ancient cities used all available resources for both construction and daily life. Cities today, such as Tokyo and Porto, are testing waste-to-energy systems, where urban waste is converted into renewable energy or new materials. By reinterpreting ancient practices of waste management, we can build systems that reduce reliance on landfills and incinerators. Zero-waste architecture. Some modern cities are using closed-loop architectural systems, which emulate how ancient civilizations used resources efficiently. In places like Rome, for example, construction was often based on local materials like stone, clay, and marble, which could be easily replenished. Today's zero-waste buildings are designed to use modular construction, allowing materials to be reused and repurposed instead of discarded. Energy-positive buildings, such as those being developed in Germany and Scandinavia, go a step further by producing more energy than they consume, a concept that resonates with the self-sufficiency of ancient cities like Pompeii, where urban systems were designed to work together for maximum efficiency. Agricultural integration. Ancient cities often incorporated farming and food production within the urban space. The Maya cities integrated terraces and irrigation systems to support agriculture in otherwise inhospitable environments. Today, cities like Singapore and New York are exploring urban farming and vertical agriculture as ways to integrate food production with urban development, using hydroponic and aquaponic systems. Modern cities can reduce their reliance on external food sources and increase urban resilience to supply chain disruptions. 3. Fostering social and cultural connectivity. Ancient urban design as a model for modern cities. Urban design is not just about physical infrastructure, it's also about fostering human connection. Many ancient cities were designed with community and social cohesion in mind. The agoras of ancient Greece, the forums of ancient Rome, and the piazzas of Italy were places for social, political, and cultural interaction, as well as commerce. These spaces promoted democratic engagement, community bonding, and the free exchange of ideas. Designing for people, not cars. The compact, walkable design of many ancient cities is a model for how modern cities can be designed around the needs of pedestrians rather than automobiles. Ancient Rome, with its network of insulas, apartment buildings, and pedestrianized streets, was a prototype for modern, car-free city design. Today, cities like Copenhagen, Barcelona, and Portland are shifting away from car-centric urban planning and designing spaces that prioritize pedestrian movement, cycling, and public transport. These principles encourage a healthier, more connected urban life, reminiscent of ancient urban environments where people interacted and engaged in communal activities. Mixed-use spaces. Ancient cities often mixed residential, commercial, and civic functions within the same urban space, creating lively, integrated communities. The Roman insulae, multi-story apartment blocks, had shops and markets on the lower floors and residences above. Today, the principles of mixed-use development are being revived in urban planning to reduce urban sprawl and encourage interaction between different parts of society. Cities like Vancouver and Melbourne are adopting these principles, creating vibrant neighborhoods that blend housing, shops, restaurants, and workspaces in a seamless and sustainable way. Public space as a social and cultural hub. Public spaces were the beating heart of ancient cities, and today's urban planners are rediscovering their importance for civic engagement, social justice, and cultural expression. The Roman Forum, for instance, wasn't just a marketplace, it was also a venue for public debates, legal proceedings, and political discourse. Modern urban spaces such as New York's Times Square or London's Trafalgar Square continue this tradition by serving as hubs for cultural and political activities. By creating accessible, inclusive public spaces in which people can connect, share ideas, and engage in civic life, we can foster a more democratic, socially cohesive urban environment. 4. Learning from ancient cities for future resilience. The resilience of ancient cities, especially in the face of natural disasters, climate change, and other environmental challenges, offers valuable insights for building cities that can withstand modern crises. Disaster-resilient infrastructure. The Maya and Inca civilizations built cities high in the mountains, using terracing and irrigation systems that could withstand floods and soil erosion. Pompeii and Herculaneum were designed to be earthquake-resistant, using techniques like flexible masonry and seismic-proof foundations. By learning from these examples, modern urban planners can design cities that are better prepared for natural disasters like floods, earthquakes, and storms. In cities like Tokyo, San Francisco, and Mexico City, modern engineering is being combined with ancient techniques to create earthquake-resistant infrastructure that can minimize loss of life and damage. Ecological adaptation. Ancient cities, such as those in Mesopotamia, were built with the understanding that the surrounding landscape could provide both resources and risks. The Babylonian hanging gardens were not only an aesthetic feature but also part of a larger effort to adapt to the challenging environment. By embracing the principles of ecological design, cities can adapt to the unique environmental challenges they face today. This might include integrating flood defenses, natural ventilation systems, and sustainable agriculture into the urban fabric to reduce vulnerability to climate change. Conclusion. Designing for the future with the wisdom of the past. As we move forward into an era of rapid urbanization, technological advancement, and climate uncertainty, the lessons of ancient cities remain as relevant as ever. By blending modern technology with ancient wisdom, we can create cities that are not only more sustainable, resilient, and livable but also deeply rooted in our collective history.